guess this is it. And now, live from the world-famous South Texas Preparatory Academy campus here in Edinburgh, Texas, home of the ultimate Spartan, it's Mr. Gill's Classroom, starring the headliner, the main event, the number one draft pick, the teacher with the most, always the great host, the number one, the only one, the greatest teacher of all time, Mr. Gill. Oh, hey everybody, how you doing? I can't hear you guys. Oh, you're welcome. Thank you very much for cheering for me. I appreciate all of that. Alrighty, so let's go and see how we can help you guys today and get some stuff done. Kind of doing this whole mess up here. Again, this is South Texas Preparatory. Yeah, you don't need to clap for me twice. Just calm down a little bit. Turn off my theme music and stuff like that. Let's help you out today. Let's kick in my. Oh, I gotta get my board ready. Hang on a second. Gotta get my world famous Moby tablet. Not sponsoring the stream today, but we'll see what happens. And we're gonna go from there. Let me do one little thing here. Let me move this over to the screen there. Moving it to a secondary screen so I can kind of see what's going on. Seems there's a little bit of lag here. There might be that sort of thing. So, be careful of that. Let me see, unmute. Move this over. Oh, there we go. I actually hear myself, so we don't want to talk to myself. So, alrighty. So, you guys had some issues, and the best way to do this, since we're asking a lot of questions today, is go to the It's Learning app if you can, either via the website like this or via the phone. And I know there's comments and stuff on YouTube, but I have to look at this really big screen way over there, and to get my second screen, because I don't have a dual monitor setup or a triple monitor setup, whatever else. So it's easier to just do the messenger thing to tell me which question you might need some help on. I know I could probably sit there and do some work with, hey, look at my channel and whatnot. I just don't want to work that hard at it. I haven't done this in a whole long time. So actually, I used to have a channel a long time ago. Let me see where we're at. So it's easier to just do the messenger thing to tell me which question you might need some help on. I know I could probably sit there and... Wow, I was just hearing myself. That was really weird. No idea where comments are or anything else. So it might be best if you guys would... see, I can't remember how to put comments on this. Oh well, we'll do it later. Send me the messenger through the It's Learning app and or via the website. A good question that you may want to have, and some of you already have done that. So I'm going to kind of do that. One thing that we like to make sure that you do understand to use the Desmos calculators if you do not have a graphing calculator at home or whatever else, because we will need one eventually. Right now we're just doing simplifying radicals and whatnot, so you don't need to worry too much about that. Going to and if you want to go all the way down here to where it says scientific, that's probably the bestest calculator we're going to get with this. You really don't need anything more than the power of this, and it does quite a bit with this. So I'm going to see how small. Oh, that's as small as I can get with that. That's cool. In terms of learning. Okay, thanks. Okay, someone sent me something cool. Alrighty. Now that I am live streaming and going through this, going to do some questions here. And let's see. Well, let's start up a brand new page. And somebody had asked questions 23 to 26 on the homework for simplifying radicals. So let's get started with some stuff like that. By the way, a great tool in Windows. I know a lot of you guys know how to do screenshots and stuff, but there's this thing called the snipping tool, and it works really lickety-split. I can't stress that enough. And this might be useful, like if you want to send me a picture of a specific question. And let me show you how this tool works.
If you don't have it on your Windows machine, you'll have to download it through the Windows App Store. I'm sure Apple has something like that. Or through your phone, take a picture of it, and that helps too. So I can find out which one it is, tell me what worksheet it is and whatnot. But this, when I click New, I can actually just literally select the section that I want. Oops, I did it over the tool. And I have this. It kind of makes the screen a little bit gray, as you can kind of see. And I'm just going to highlight some stuff up here and see how it has my tools up there. There's the little screenshot of it right there. It's right up here. You can actually write on it, whatever else you want to do, and have fun with it. But the reason of bringing that up is you can go to File and save that as a JPEG or whatever else you want to do. Save it to your desktop or wherever you need to. And that's the one you can send me if you were using a desktop computer, that question you're having specific problems with. Or just say, hey, sir, I did this problem, and I'm not sure if I did this one right. And that's kind of nice. If you want to take the whole screenshot, that's fine too. I'm pretty flexible. Most of you guys do know that. Oops, I actually need that tool back up, so I'm going to keep that tool. I'm going to slide that over here. No, you know what? I'm just going to keep it there. Because even though I have dual screen, I can actually copy that picture. So you said 23 to 26. Let me go to, let's see, and where's the Adobe thing? Over here, and it was 23 to 26. 23 to 26, where is that? Why am I missing that one? Do I not have that? 23 to 26. Did I give you guys the different one? Oh, I got the wrong page up. Dude. 23 to 26. There he is. Okay. So we have this. Go over here. Click. And let's look at 23. 23 was this one. And I'm going to copy that over. Go over this side and hit paste. And then while I'm at it, let's make another one and go to see new, and let's try 26, see what happens there. And come over here, copy it, go over here, paste. I know I'm talking to myself. Well, I am kind of like the only one here, so gotta listen to myself sometime, right? Alrighty, so we have this, moving open, and we have this one. All right, so I think this is 23, and this was finding square roots. All right, so remember what square roots were. We'll get to the letters in a little bit, and some people are still having problems with that. These are the numbers that were perfect squares, like 1, 4, 9, 16, 25, 36, 49. That's 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11. 12 times 12 and 13 times 13. No, it's not 136, 169. And then 14 is 196, and then 225, etc. And we find those, right? But 512, trying to find any perfect squares that divide into it. And what I kind of gave you as a good suggestion was, think of half of that number. All right, so we have this. I'm going to go to Desmos. And 512. So I got 512, right? And I'm going to divide it by 2. So I divide it by 2. And I hit enter, 256. All right, why that 256? That tells me none of the perfect squares bigger than 256, which I believe is 289 is the next one after that. In other words, after that, they won't work. None of them are going to divide into it evenly. So forgetting that. So, on all the homework. Okay, well, that's not a good thing. Well, we'll get to you. We'll see how much we can do with this. All right, so what you want to do is take numbers that are less than 512 and see which ones divide into. So you just keep going with Desmos, and you start saying, all righty. So you take 512, and then you try dividing it by, well, try 289. Why not? 289. It's not going to divide in evenly. So 512 divided by 225. Oops, I messed up. 512 divided by 225. And then we have, that's 2.27. So 512, oops, delete, oops, let's just clear. 512, what was I at? 196. 196, still not there. 512 divided by 169. And we have that's not working, so 512 divided by 144. I don't know, maybe that might work. 144. Nope, still not working. 512 divided by 121. I know 100 is not going to work into it. So 512. I'm delete, clear. 512 divided by 81. Getting closer, I think. 512 divided by 64. 8 times. Okay, that's the biggest number that's going to work. So what we do is we take that 512 and we're going to change to 64 times, in this case, what was that number again? It was 8, so times 8. 564. Did I miss one? What's one? No, okay, never mind. Even if I did 64, which is what I did here. And this is a good thing to start off with this one anyway. 64 is 8, but in square root of 8, that is also 4 times 2. So what about this? I could still break that down a little bit even further. So this is 2 square roots of 2. Now I have this 16 square roots of 2. Okay. I think what's 4 times 64? I think I missed one. What's 64 times 4? And no, I'm not seeing your comments, so, it is what it is. 256. Did I divide wrong? I must have done that or hit the wrong key, because I thought I did 256 earlier. Oh, went exactly twice. All right, so 512 also should have been 256 times 2. And 256, what is the square root of 256, by the way? I did miss that one. The square root of 256 is 16. So this is 16 square roots of 2. So I could have done it that way, which would have been a lot faster saving step. Now, usually the numbers isn't the biggest problem for you guys. It seems to be, what about the variables? And what we had talked about on the videos and in class before we actually left before break was, okay, look at p to the 9th. P to the 9th is not an even exponent. We need the even exponents to find the nice even factors. So like p squared. When you multiply it, it gets you p to the 4th. P cubed is p to the 6th. P4 is p to the 8th. P5, these are the square roots of these. The square root of p to the 10th is p to the 5. Square root of p to the 8th is p to the 4. Square root of p to the 6th, p to the 3. P to the 4 is p to the 2. Notice that all of these are even numbers. So what we need to do, and what we do in math, is we need to clean up a little bit of as much as we can of this problem. So p to the 9th is the same way as saying p to the 8 times p to the 1st. So what we're going to do is, when you do the square root of this and the square root of this, you could do square root of p to the 8th. The square root of p to the 8th is p to the 4th. So p to the 9th is p to the 4th. So I'm going to put p to the 4 times. But what about the other p that's left? I'm just going to leave it inside of there. What about, let me change my pen color to q to the 4th. Q to the 4th, the square root of q to the 4th is q squared because it's even. Q2 times q2 is q4. So this is just q squared. You're done. And also, here's another thing that's happening too. And I remember a couple students were doing this before break. They were doing p to the 8th and they didn't do anything with this, which is correct. You are done. What they kept doing was, let's keep square rooting this and square rooting this. And you got p. I'm like, what are you doing? Once you've done the square root, you should not need that symbol there again. So don't use it again. So that should tell you, what is r to the 10th? R to the 5th. Now, we're going to, it's got a little of a mess in there. You got this radical here and a radical there. So I'm going to put everything on the outside together. So 16, p to the 4th, q squared, and p to the 5th. And then inside the radicals, everything left over. The square root of 2 that I see there, and the p to the 1st. So p, just like this. So what about 26? Same idea. So we're going to go with this. Oh, Microsoft Form perfected by iPad Pro, whatever. I don't know why I'm getting news here. No. Oh, no, I just cleared out that. Okay. I'll be back, don't worry. I'll get decimals back. Alrighty. The square root of 27. Okay, what's a perfect square that goes into 27? If you can't think of big numbers, start off by dividing 27 by 2. So let me bring up Desmos again. Let me see here. I need a new window. So, and there it is over here for some reason. And let's put in Desmos. I know I should have made this a bookmark, right? I don't want to hear about it. Shush. Anyway, we have this. And let's bring you back over here. This big TV screens are really weird. Okay, so 27. 27 divided by 2. All right, you have 13.5. That means no matter what, your square root cannot be bigger than any number bigger than 13.5. Well, there's 16. 16 won't divide into 27. Neither will 25. So the biggest numbers would be these numbers. So you try 9 and you try 4. See what happens. Does 9 divide into 27? Of course it does. It divides into 3 times. So 27 turns into the square root of 9 times the square root of 3. Now, what about the square root of 10? The square root of x to the 10. That one comes out nice and simple because it's even. You just divide it by 2, which was in our notes. X to the 5th. All right, what about y to the 5th? It's an odd exponent. You got to take one out, leave it inside the radical, and you're actually going to do the radical of, or square root of y to the 4th times y to the 1st. That's what you're going to do. What about z to the 17th? Let me change my color one last time. And z to the 17th. That was, yeah, it's odd. So you got to take one of those out, leave it inside the radical, so you have z to the 16th in there. And you have z to the 1st left inside of there. All right, got a lot of mess in there. And I know some of you are even saying, but sir, there's that -8 out front, right? Okay, it's -8 times everything inside of there. So -8 times all of that. What our answer is going to be. So we start breaking up everything, the square rooting everything that we can. What's the square root of 9? 3. So I'm going to put a times 3 there. We'll deal with that in a minute. The x to the 5th is already outside, so I'm going to bring it down. What about this square root of 3? Well, it's stuck inside the radical, so I'm going to put a big old radical here, and I'm going to put a 3 there. What about this y to the 4th? The square root of y to the 4th should be y squared. Just divide it by 2. It's not hard. What about this y to the 1st? It's stuck inside of there. You leave it inside the radical. What about z's? Z to the 16th. Divided by 2, you have z to the 8th. What about this z to the 1st? It's stuck there. Z to the 1st. Now, anything we hear we can also simplify but a little bit more? Yeah, we can clean this up. -8 times 3 is -24. So your final answer looks like this. Remember, we're doing something to learn to simplify. We haven't really gotten to the solving and all that other fun stuff yet. So this is your final answer for that one. So hopefully we can work with some of that on 23 through 26. Now, let's go back, and someone had asked also about some of the cubes. So simplifying radicals, and not that one, there it is. Something about the cube roots. You were having some issues with that, right? All right. Let me zoom in a little bit so I can get a good picture. And snipping tool. All right. Cube roots work the same sort of way. But remember that, like square roots, it's a number times another number gets you the square root. The cube root is number times number times number. You need 3 of those. So what number times itself 3 times gets you the cube root of something? So for example, the cube root of 27. You need a number times itself 3 times. It has to be the same number in each of those blanks. That gets you 27. Well, that's 3 times 3 times 3. So the cube root of 27 is this. Hold on, it's cool. Okay, never mind. What about -27? Well, -27 is -3 times -3 times -3. So there's the same -3 there. So negative cube roots can be done. You can't do with square roots, but you can do cube roots. So what about, okay, one, that's kind of easy one. 216, I think 216. All right, how would you do that? With and without a calculator? Well, the easiest way to do this one with a calculator, there is a way to do cube roots and stuff. You see this button here on Desmos? It has this little N in there. So what you want to do, and I think if I'm going to do this right, hang on. You press the 3, and then you press that button. Nope, never mind. I got to press the button first. Notice how the cursor's up there, and I'm going to put 3 in there. And then I'm going to move over here, and you go to, what was it, 216? 216. Notice that the answer is 6 already. By the way, you do have options to get the apps for both the scientific calculator and the graphing calculator to use on your phones. It's both on the Google Play Store as well as the Apple Store. And in fact, I have it here right now, and I actually use it at home since I don't carry a graphing calculator with me all the time. So I use the exact same calculator. It looks exactly the same thing on the screen. And when we get to graphing, which is kind of useful, does all the graphing stuff. Pops open, and we get the graphs. So you can use those as well. So you don't necessarily have to be on the computer to do these. Would recommend trying to get those apps, and if you use your parents' phone, tell them to put the apps on there so you can do that. All right, what was I doing? Okay, so what about then, okay, we did 216, right? Well, why not 227, for example? Well, look, 227, there is no number that's a nice whole number that will get you the cube root of 227. Is that what the number I had? So I'm going to go up here. Click in here. We have, no, let me clear that out. The cube root, and I'm going to put a 3 in there. Click over here, 227, and we hit enter. Notice that it's 6.1 something something. So it doesn't have a pretty perfect cube root. That doesn't mean we can't do something with cube roots. So 128. If I ask you to simplify the cube root of 128, first off, the first thing you try to do is there a number times itself 3 times that gets you the cube root of, did I do that again? I clicked out. Oh my gosh. No, it's right there, isn't it? I'm going to bring it. Okay, come on. Where are you? I wish they made like a Windows app for Desmos. That would be awesome. I would really appreciate that. So if the people who make Desmos on that, you get on that for me, I'd appreciate that. All right, the cube root of 128. So cube root 128. And I'm going to click inside of here, 128. I notice it doesn't have a pretty perfect cube root. It's a 5 point something something. However, what are perfect cubes? That would be like, what's 2 to the 3rd power? So I'm going to go to, clear all out, 2, raise it to the power of 3. 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4. And we had given you a list of those perfect cubes in class. Remember, we had done that. We wrote down the numbers 8 and 27 and 64 and the 3. 4 times 4 times 4, 5 times 5, 6 times 6 times 6, 7 times 7, etc., etc. There was that list. All right, again, 128 divided by 2. Okay, I'm going to take 128 divided by 2. So 128 divided by 2. It's kind of important just to keep practicing this. 64. The biggest cube root that could fit in there is going to be 64. Okay? No matter what. It's one of those cool things. So in other words, wait a minute. 64 goes into 128. How many times? 128 divided by 64. You get 2. So that would mean you'd get a cube root of 64 times the cube root of 2. Now the cube root of 64, well, this was 2 cubed, this was 3 cubed, this is 4 to the 3rd power. It would be just 4. So this turns into 4. What about the cube root of 2? 2 is not on this list. It doesn't have a perfect cube root. You're done. You're stuck with that part. So you have this. Hi. I'm doing a live stream, sir. What's up, sir?
Oh, no.
Mr. Romero's here. Hi, everybody. Okay, what's up? Yes, I'm actually live on YouTube.
Sorry.
You need help? I'll talk to you later.
No, I guess I thought we.
Talk to you later. Okay. Kind of cool. Famous. Alrighty. Let's see. Going on from here. So what if I throw some variables in there? Same type of idea. Trying to. Oh, I touched my face. Oh my gosh. Oh well. I don't have a. I don't have anything like a coronavirus, whatever that stuff is. All right. Cube root of x to the 9th versus cube root of x to the 10th versus cube root of x to the 11th. Okay. Can I split up x to the 9th 3 different ways x times x times x, with some exponent in here and here and here. That would get you to the 9. And remember, you're adding exponents to get to that number. So in other words, you have this. There's something going on my screen. Let me get over here. There. It's distracting me. Alrighty. Alrighty. So meaning this. Would this work? 2, 2, and 2. Would 2 plus 2 plus 2 get you 9? No. Okay. What about 3? 3, 3, and 3. Is 3 plus 3 plus 3 9? Sure is. So that tells you that the cube root of x to the 9th is just x to the 3rd, one of those. But what about 10? Is there a way to split this up evenly? They have to have the same numbers. In other words, does 10 divide by 3 evenly? No, it doesn't. Well, 3.3 repeating. Okay, that's not an exponent we use in this class, so it doesn't actually work. However, you take the cube root of x to the 10, and you could pull out 1 or 2 of those. In this case, 1, and I can get x to the 9th again. There's 9 of 1 adds up to 10. What's the cube root of 9? X to the 3rd. We already just did it. What about this cube root of x to the 1st? It doesn't do anything. So there's cube root of x to the 1st. So your final answer, let me make that a little bit nicer. X to the 3rd times the cube root of x, just like that. Okay. What about cube root of x to the 11th then? Okay. Oops. There it is. I thought I wrote it, but well. Same idea. I need to get rid of enough of these variables so I can turn it into something I can divide by 3. Now, I can't go to 12. It's too many. So in other words, I could do this. The cube root of x to the 9th times the cube root of x to the 2nd power. Why? 9 plus 2 is 11. There is a cube root of 9, so that must mean this is going to be x to the 3rd. What about the rest of this? The cube root of x squared. That doesn't do anything. You're done. Now, let me get to a couple questions that we have, let's say, on our notes. So, let's pick this one. New. And I'm going to pick... No, I want that one. Let's pick something a little bit more meat to it. There we go. I know you guys are hungry. Okay, let's go over here. And we have this. Paste. Let me get another one while we're at it. And these were off the notes that we kind of did in class. We did do them all, the note sheet. So let's do, hey, let's do a -1. Yeah, that'd be awesome, sir. Okay, no problem. And copy. Come over here, click in here, paste. Alrighty. And I'll rewrite these if I need to make them clear or not. Alrighty. Looks pretty good there. Alrighty. No one's sending me messages. So either A, you're not watching the whole thing, B, you're kind of paying attention profusely, or you're all doing good. So got a couple kids in Math H. They're not getting their live stream today. Just Algebra today. I got one student that says, I have a question on all of the homework, then you better be asking a couple questions on this one right now. So, unless you're doing pretty good with this. I will do a little bit of the adding and subtracting a little bit before I leave today. So, I got about another 20-ish minutes there. Okay? Alrighty. Big numbers here. 250. Let me go back up one. And I'm going to back up 2. There, I want these numbers. So, freeform this. And bring it over. We're going to copy, dump it over here, back to this one. Hey, don't be freaking out on me just because everything's running on this computer. All right. I'm looking for do any of those numbers on the left-hand side of the screen actually divide into -250. We're not doing the number 2. We'll worry about this other variable stuff in a little bit, so just relax a little bit. And this one is a totally different problem, so put the dots there. Alrighty, so 250. Do any of these numbers divide into 250? And you want the biggest one possible. So the biggest number here possible is 125. So I'm going to go to Desmos, and I'm going to take -250, or just go to 250 actually, divide by 125. We'll be live streaming for a little bit longer. 2. So we have 2. All right. So there's a 2 that goes inside of there. Now, what I've told you guys to do is I want you to do this. You have the cube root, and we said 125 times 2. So I'm going to put that in there, and it's the cube root of 2. Alrighty, but where does the negative go? Since we're going to try to get it out of there with cube roots, you can do that. I'm going to put it right there. Okay, so that's what I'm going to do. So the cube root of 125. Okay, cube root of 125. In this case, what is the cube root of? Well, what was the cube root of 125? It was 5, right? So in other words, we're going to make it -5. That's all you got to write. What about the cube root of 2? We're going to leave it. Not going to mess with it. So there we go. What about everything else? What about the cube root of a to the third? Is there a way to divide that evenly by 3? Well, take 3 divided by 3. That's 1. That must mean each one of the a to the third power is a to the first, a to the first, and a to the first. So that would tell you, because 1 plus 1 plus 1 is 3. So what's the cube root of a to the third? Just a to the first. So this part is a to the first. What about b to the fourth now? Let me change. I'm in red now. Okay. So b to the fourth. 4 does not divide by 3 evenly. So divide, I need a way to be able to. So take out as many as you need to get to the biggest number that would divide by 3. So in other words, b to the fourth is the same thing as b to the fourth times b to the first. So, whoops. Got distracted. Sorry. b to the third times b to the first. I almost got confused. Alrighty. So, b to the fourth, the cube root of b to the fourth changes to b to the third times b to the first. So what is the cube root of b to the third? That is b to the first power. What about this b to the first? It's stuck inside the radical. Alrighty, so that goes with the stuff over here. Let's put it all together. Stuff on the outside we leave on the outside. So -5 b to the first. I'm going to put this there. I'm going to put this there. What about what's left inside of the radical? Cube root. There's a 2 there. There's a b to the first. How does that look? Did I forget anything? Yeah, I know there's a little delay here, so why even ask, right? Okay, anyway, you guys would all be messaging me about 10 minutes anyway. But look, I forgot this a to the first, so I don't want to forget that, and I'm going to push it in there. And it does not matter if you do it alphabetically or not. I'm not going to cry about it. You know, if you put B before A, it's okay. Do I have to put the number 1s there? No, most people don't. No book does that ever, so it's up to you. So your final answer looks like this one here. Okay, I'm going to do this next problem, and then I'm going to try to do some of the requested adding and subtracting problems, because there was some people that had some problems with those. All right, here we go. Cube root. Thinking of the biggest number in this list that divides into 48. Well, 64 sure doesn't. Does 27. So we try 27. So go over here. You try 48. Does it divide by 27? No. What about 8? So 48 divided by 8. Sure does. 6 times. Alrighty. But how many times? You said 6, right? What about that negative sign? I said take that negative sign and take it out with the one that you're going to simplify. Meaning this. I'm going to write cube root of -8. That's where the negative one is, because that's the one that I'm going to simplify. And I'm stuck with the other stuff, so cube root of 6. What about the 7? We'll deal with that, but I'll bring it down for you guys. You're all worried about it, right? Okay. Back to here. X to the first. X to the first. That does not divide by 3 evenly, so that's going to get stuck inside of there. So X to the first. Sorry, X. I hate when your X is stuck, right? A little humor today. Okay, not funny. Okay, I'm sorry. All right. Y to the 9th. Okay, 9 can be divided by 3. So that must mean, what is the cube root of y to the 9th? How can you split y to the 9th 3 even places and have the exact same number? Remember, you're adding the exponents to get to the 9. Just take that 9 divided by 3. You get 3. So this right here is going to turn into y to the 3rd. What about z? All right, we need to fix z up. The 5th power cannot be divided by 3. So in other words, what's the next biggest one that would work? That would be 3. So I'm going to need to take 2 of them out and change it to look like this. The cube root of z to the 3rd times z to the second. Z to the third. What's the cube root of z to the third? We've done that one already, okay? That's to the first power, so z to the first power. What about this other stuff that's stuck inside of there? It's stuck inside of there. Not much you can do about it. Alrighty, now let's put everything together on the outside. Oh wait, we're not done yet. We didn't finish. I'm sorry. What's the cube root of negative 8? Well, the cube root of just 8 is 2. The cube root of negative 8 must be negative 2. So there's negative 2 here. The cube root of the 6 isn't going to do anything. The cube root of x to the first isn't going to do anything. The y to the third comes out front because it doesn't have a radical on it. And that z to the first is also over here. So I'm going to put z there. What about the 7? I'm going to bring it down for now. Put everything inside the radical that's stuck inside there. So I had the cube root of 6. Cube root of x to the first, x. The cube root of z squared, there it is. Does that look good? Well, you're going to probably say, no, Mr. Gill, you didn't simplify. What's 7 times negative 2? Negative 14, y to the third, times z, cube root, 6x, z squared. All right. So, we have this. Now, that's just doing the square roots and the cube roots. So hopefully you kind of understand that a little bit better going on with this. If you still got a few questions on that, try to take a picture of the question itself, what you've done so far on it, and ask me, does this look good to me? Or give me some suggestions, we'll do that. Don't just send me a blank picture and have me expect you to do it. We need you to try, okay? Now I'm going to do a little bit of the adding, subtracting. I've got about another 10-ish minutes. Maybe 15. I'm not going to try to do a whole full hour here, so we're going to try to do that. Alrighty, so adding and subtracting. We're having some problems with that. Let's do, we do number 4? I hope so, right? Alright, let's do number 4. That looked like a lot. And 4 look good. And we're going to copy it. Come over here. Hit paste. Alright. Now, this is just square roots, not cube roots, right? Alright. I got a cough. Sorry, and I know you all heard that. If you're hooked up to your Xbox and playing off the YouTube app, playing on your flat screen with your surround sound system, waking up your parents or whatever else you're doing, that's awesome. Okay. I think that would be kind of awesome, me to live stream right to your house, so maybe next time y'all can do that. I know your parents will tell you, no, they're busy playing Animal Crossing on Nintendo Switch, right? Or, oh wait, Doom's out. Oh, that's not a good game to play for kids. It's got a lot of horror and blood and stuff. Don't do that. Or Mortal Kombat. Okay, not a good thing. Mortal Kombat, no, don't play that one. Anyways. Square roots. Remember what square roots were? Those were the ones all the way at the very beginning. Okay, thinking about numbers. 9, 14, 16, 25, 36. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. 13 times 13. And I did it again. 196. No. Yeah, 13, 13, 169. 196 and 225. And things like that, right? Trying to think of the biggest number. Now we're doing square roots. Which of these is the biggest number divides into 500? Now, I'm going to kind of do this problem 2 ways. And I'm going to teach a little trick to this. So if you're watching this live stream, you're going to get a hardcore trick on this. And I'm not kidding either. But I'm not going to tell you what it is just yet. I bet some of you already know because you're smart geniuses. But you know what? That's just because you go to STPA, right? No, I'm saying STPA in the house. Okay, anyway, 1 to 1, 500. All right, of these numbers, what's the biggest number that divides into there? Well, first start with 500, divided by 2, 250. Okay, 225 doesn't divide into it. Neither is 196, but I know all the way back here, 100 does. Okay, so I'm going to divide 500 by 100. Go big. Some of you that have turned stuff in, like, I'm going to divide it by 4. Really? That's not even a big number. You want to go big, otherwise you're never going to get this to simplify right, and you're going to work 10 times harder. Okay? We've talked about that. So 100. Why 100, sir? Well, this is 100 times the square root of 5. Okay. What's the square root of 100 here? 10. What about the square root of 5? Can't do anything. Square root of 5. Plus, what about this square root of 20? All right, 20. Half of 20 is 10. That means my answer that I'm going to divide into it can't be bigger than 10. All right, 9 and 4, the only two numbers that I'm going to attempt to plug into and divide into 20. 9 does not divide into 20 evenly, but 4 does. 4 happens to be the only number it does. All right, so we have 4 times 5. There's a square root of 5 there. There's a square root of 5 there. Anyway, what's the square root of 4 here? 2. What about that square root of 5? Nothing. Bring it down. Now 11 square roots of 5. 5 can't be broken down any further with these perfect squares, so we're just going to bring it down. Now, you are not done yet, because you have to collect any and all like terms. They have to have the exact same radical with the same exponents, same all that same stuff. Like terms. So if I have 10 square roots of 5, plus 2 square roots of 5, plus 11 square roots of 5, 10 plus 2 is 12, plus 11 is 23. No, it's not. Yeah, 23 square roots of 5. There you go. Just like that. Now, some of you guys might have caught on to a little trick, and that's awesome. Watch this. I'm going to go with the smallest number. I'm looking at 5. And I go back, and I'm like, okay, I look at that 5. Is there a way to take that 5 and divide it into 20? Sure. How many times? 4, right? Oh, wait a minute. That's what we just did over here. So I'm trying to see if I could force this 5 to be this also a 5. That means I'm going to collect it later. Oh, what's the square root of 4? Square root of 4 in this problem was 2. Don't write square root of 2, just 2. Square roots of 5. Plus this 11 square roots of 5. Now we could collect that. We'll get to that in a minute. But you notice how we have a 5 there. We have a 5 there. We tried to see about 10 minutes. See if I could divide 500 by 5. And you can. How many times? 100. So 100 times that 5. Square root of 100 is 10. Square roots of 5. Now I combine them. And we got 23 square roots of 5. So that's a pretty neat little trick if you ask me. Right? Okay. Let me do that again on a different problem that somebody was having problems with yesterday. Do the same sort of thing. Let's see. You know what? Let's try 7. I try not to say names of you kids on here because, you know, it is live and everything else, and I don't want to embarrass anybody because everybody has questions. So, on top of, you know, I don't want you getting all mad and crying that I made fun of you because remember, this is global. YouTube is public. Everybody can see me. So, you know, Mr. Gill has no fear in that, by the way. It's like he makes enough fun of himself and things like that. And Mrs. Ultimate Spartan, she does too. So, regardless. So, I'm looking at this problem here. Okay. We could do it the way we done previously, but let's kind of see something. 7. Remember over here we had that 7. Let me copy these pieces over here. And over here. I'm going to bring them and copy it. I'm going to dump that so I don't see that again. And go back over here and hit paste. All right. None of those numbers divide into 7 evenly. Okay, but watch this. Does 7 divide into 32? No, it doesn't, sir. Okay, cool. Does 7 divide into 175? Wait a minute. I think it does. 175 divided by 7. 25 times. Wait a minute. What do you know about the number 25 that's useful right now? There's a square root of 25, isn't there? Okay. So, in other words, this is a square root of 7 times the square root of 25. And I have a negative 4 out front of it. I can't do anything with the square root of 7. It's stuck there. But there is a square root of 25. That is 5. And negative 4 times 5 is negative 20 square roots of 7. Hey, that's going to combine with this 3 square roots of 7, isn't it? Alrighty, cool. But what about the 2 square roots of 32? Alright, 32 does not divide evenly by 7. And I'm going to do it right here. 32 divided by 7. And you have this. It's 4.5. No, that's not going to work. However, are there any other perfect squares that divide into 32? Well, 16 does. It's the big. I know someone's going 4 times 8. Okay, let's go through this again. Square root of 32, 4 times 8. We're going to go with your small number because we're going to show you how much more work you got. Square root of 4 is 2. 2 squared to 8, and you think that you're done. Unfortunately, you always have to go back to that list and say, can I divide it by any of these other? And your answer is yes. 8 also divides by 4. So that means you have to do this process here again. Otherwise, it's incorrect. It's not correctly simplified. So there's the square root of 4, which is 2. And then you have this. You have 4 squared to 2. So you're making yourself do an extra step. Or you're not going to catch yourself to do that. And it's going to be wrong. Because you're going too small. You want to go big. You want the biggest number possible. 32. Half of 32 is 16. 16 is on that list. How many times does 16 go into 32? Twice. So we have, let me change this to red. Ooh, I don't want that color on there. One more. So we have 2. The square root of 32 turns into 16 times the square root of 2. What is the square root of this 16? It's 4. What's this 2 times 4 in here? 8. Square roots of 2. Now, it's positive, so I'm going to bring this down all the way. So let me write this nicer next to one another so you see this. 3 square roots of 7 plus 8 square roots of 2 minus 20 square roots of 7. What do you notice? The 2 ones are in green, right? Whoops, I messed up. Then I wrote 3. I fixed it. 7. Can I put anything together? The answer is yes. You can put this collecting with this one. So what's 3 of those minus 20 of those? And if you can't do your negatives, please do it on a calculator. So 3 minus 20. So 3 minus 20 gives you an answer of negative 17. So negative 17 square roots of 7. What about the other thing? You can't combine it. It's not a like term. There you go. So that's all you have to do for adding and subtracting. It's the same things that you've been doing. You just have to do each individual one. And then you're going to add or subtract them, okay? So give it your best shots with those. I do hope that this has been helpful today. If you have any other questions, I'm going to try to look at the It's Learning Messenger today as often as I can to help you guys. I'm going to show you that as well. Let's see, where's it at? There's the YouTube. No, I don't want that one. I don't have the Learning app up there anymore. Okay. So let me put this up here. It's Learning, and you see this. Go to the message. If you have not done so, you've seen that there's messages up here for me. I'm not going to click it because it shows your names. But there's a couple things in there that is kind of neat. You can message each other. So if you do a message and you kind of search for the name, you can look up someone's last name or first name. You can just and then send them a message as well. You can also make group chat things if you wanted to within there. And it works for all the students, including students in other classes. So use that as much as you can to kind of talk to me as well as your teachers. Okay, it's really kind of important. The other important things that I need to make sure you do today is make sure that you are always wearing your ID at school. Always have it either on a clip or a lanyard. Okay, it's really kind of important. The temperature today is going to be 94 degrees. There's lots of sunshine. Pretty nice. Go outside and get some sunshine. Please don't stay in your house all day. It's really, really boring. Get outside every 45 minutes. Go sit outside for like 5 to 10 minutes. I know your parents are gonna think you're weird, but just do it anyway to get fresh air. If it's raining, don't get wet. It's kind of dumb. You know what I'm saying? You don't need to get sick. It's gonna be 96 degrees tomorrow and 94 degrees on Friday, and kind of windy. And if you are having some issues with the whole it's learning type of thing or can't log in and whatnot, I shut that one down too also. Make sure that you do call the tech support line. I do believe they sent that messages out. Area code 956-514-4277 or 956-514-4285. And again, if you have any questions, message me through the app. It's a whole lot better because I'm carrying my phone with me all the time. I'm not logging in on my computer on my email because I don't check my emails on my phone. Yes, I keep work and life separate. It's one of those things. So should you. And now it's time for the end of the day. I'd like you to have a good day, and maybe next time I'll have a guest appearance of somebody. So when will my next live stream be? I'm not as sure exactly, but I will message you. It might be Friday, it might be Monday, depending if they're gonna let me work. And yes, I'm at school just for you guys. Alrighty, so you guys have a great day. Take care.